What if the ground beneath your feet in California isn't as stable as you think? For centuries, massive tectonic plates have been grinding together, creating a hidden dance that's constantly reshaping the landscape. Is California truly shifting? And what does that mean for the millions who call it home? While many associate California's seismic activity with the infamous San Andreas Fault, a lesser-known but equally powerful geological force, the Cascadia Subduction Zone, plays a critical role in shaping the state's dynamic landscape. This article dives into the unseen forces of the Cascadia Subduction Zone, exploring its mechanics, its impact on California, and the potential consequences for the future. California is synonymous with earthquakes, largely due to the San Andreas Fault, a transform fault where tectonic plates slide past each other. However, in Northern California, a different and more complex geological process is at work: subduction. The Cascadia Subduction Zone, CSZ, is a 1,000-kilometer-long fault stretching from Northern California to British Columbia, where the Juan de Fuca Plate is diving beneath the North American plate. Unlike the San Andreas Fault, which is more famous for its potential to cause the Big One, the CSZ operates on a grander scale, capable of producing megathrust earthquakes that could reshape the region. A subduction zone occurs when one tectonic plate is forced beneath another, descending into the Earth's mantle. In the case of the CSZ, the oceanic Juan de Fuca Plate is sliding under the continental North American plate at a rate of about 4 centimeters per year. This slow but relentless movement creates immense pressure, which can be released in catastrophic earthquakes. The CSZ is located offshore, running parallel to the coast from Cape Mendocino in Northern California to Vancouver Island. While it's less discussed than the San Andreas Fault, its potential for destruction is significant, with the ability to generate earthquakes of magnitude 9.0 or higher. The San Andreas Fault grabs headlines because it runs through densely populated areas like Los Angeles and San Francisco, and its earthquakes are more frequent but typically less severe. In contrast, the CSZ is offshore and produces large earthquakes less often, every 200 to 600 years on average. However, when it does rupture, the results can be catastrophic, potentially triggering tsunamis and widespread damage. The last major CSZ earthquake occurred in 1700, with evidence preserved in Native American oral histories and geological records, such as ghost forests of drowned trees along the coast. Its relative obscurity stems from its long periods of quiescence, but scientists warn that it's only a matter of time before the next big event. Imagine the Earth's crust as a jigsaw puzzle of massive moving pieces. The Juan de Fuca Plate, a remnant of the larger Farallon Plate, is a dense oceanic plate sinking beneath the lighter continental North American plate. This process, called subduction, creates a dynamic interaction. As the Juan de Fuca Plate dives, it bends, fractures, and melts, forming volcanic arcs like the Cascade Range, which includes Mount Shasta and Lassen Peak in California. The grinding of these plates builds stress, which is released in earthquakes, some small and others potentially devastating. Insert animation description: a 3D model showing the Juan de Fuca Plate sliding under the North American plate, with arrows indicating movement and highlighted stress points where earthquakes originate. Subduction zones are among the most dynamic geological features on Earth. The CSZ is driven by the collision of tectonic plates, a process fueled by the Earth's internal heat. As the Juan de Fuca Plate subducts, it drags against the North American plate, locking them together until the stress becomes too great, resulting in a sudden slip known as a megathrust earthquake. These events are distinct from the lateral sliding of transform faults, like the San Andreas. Megathrust quakes can displace vast amounts of seawater, triggering tsunamis, as seen in the 2011 Tohoku earthquake in Japan, a comparable subduction zone event. The CSZ leaves clues of its activity in California's landscape. In Northern California, coastal areas show signs of uplift and subsidence, where the land rises or sinks due to tectonic forces. For example, near Humboldt Bay, sediment cores reveal layers of sand deposited by ancient tsunamis, while fossilized plants indicate rapid subsidence during past earthquakes. These geological fingerprints confirm that the CSZ has been active for millions of years, shaping California's rugged coastline and contributing to its mountainous terrain. Subduction also fuels volcanism. As the Juan de Fuca plate sinks, it melts, creating magma that rises to form volcanoes. In California, this process has given rise to the southern end of the Cascade Range. Mount Shasta, a dormant stratovolcano, and Lassen Peak, which last erupted in 1915, are direct results of subduction. These volcanoes remind us that the CSZ's influence extends beyond earthquakes, contributing to California's diverse geology. The CSZ's activity has profound implications for Northern California and beyond. While the southern extent of the CSZ lies near Cape Mendocino, its effects can ripple across the state. A major CSZ earthquake could impact cities like Eureka and Crescent City, which are closer to the fault, and potentially generate tsunamis that threaten coastal communities. The CSZ has a history of producing earthquakes of magnitude 8.0 to 9.0 plus, with the potential to exceed the destructive power of San Andreas Fault quakes. A magnitude 9.0 event could shake the ground for up to 5 minutes, compared to the seconds-long jolts typical of smaller quakes. Such an event would cause widespread damage to infrastructure, including roads, bridges, and buildings not designed for such prolonged shaking. Northern California's rural communities, with older infrastructure, are particularly vulnerable. One of the most significant risks associated with the CSZ is tsunamis. A megathrust earthquake could displace the ocean floor, sending waves racing toward the coast. In 1700, the last major CSZ earthquake generated a tsunami that reached Japan, as documented in historical records. Coastal areas in Northern California, including low-lying regions like Humboldt Bay, face significant tsunami risks. Modern warning systems and evacuation plans are in place, but the speed of tsunami waves, up to 500 miles per hour in deep water, leaves little time to react. Over geological time, the CSZ has sculpted California's landscape. The uplift of coastal ranges and the formation of river valleys are partly due to subduction processes. As the plates continue to interact, the land will keep shifting, creating new geological features and altering existing ones. While these changes are slow, they remind us that California's landscape is a work in progress, shaped by forces far beyond human control. Understanding the CSZ is critical for preparing for its inevitable activity. Scientists use GPS, seafloor sensors, and paleoseismic studies to monitor the zone and estimate the likelihood of future earthquakes. Current estimates suggest a 10 to 15% chance of a magnitude 9.0 plus earthquake in the next 50 years. While this may seem low, the potential consequences demand proactive measures. Communities in Northern California are working to strengthen infrastructure and improve preparedness. Retrofitting buildings, securing utilities, and developing tsunami evacuation routes are key steps. Public education campaigns also aim to raise awareness about the CSZ, encouraging residents to prepare emergency kits and learn evacuation procedures. Advances in technology are improving our ability to predict and respond to CSZ events. The Shake Alert System, a West Coast earthquake early warning network, can provide seconds to tens of seconds of warning before shaking begins, potentially saving lives. Seafloor monitoring systems are also being deployed to study the CSZ's behavior in real time, offering insights into its locked zones and stress accumulation. The Cascadia Subduction Zone is a powerful reminder that California's landscape is far from static. The slow grind of tectonic plates hidden beneath the ocean continues to shape the state's coastlines, mountains, and valleys. While the CSZ may not be as well known as the San Andreas Fault, its potential to produce megathrust earthquakes and tsunamis makes it a critical focus for scientists and communities alike. By understanding and preparing for this dynamic geological process, California can better navigate the challenges of living on an ever-shifting land. The question isn't whether the ground beneath our feet is moving. It is. The real question is how we adapt to this restless earth.